arithmetic sequences. Okay, what that is right now with number 1 we have shapes. Eventually we're going to get into numbers that are in sequential order. Okay, so what's going to happen is we're going to learn ways to make shortcuts. So if they ask you what the 100th term is, okay, or we'll see the nth term, you've got to come up with some kind of shortcut for that. All right? So first thing we have to do is we have to count up how many squares are in these boxes. I know you can't read it here, but I want you to count up how many squares are in each frame and then write it above. Okay, so for frame 1, how many did I have? 8. Frame 2? 16. Frame 3? 24. And frame 4? 32. Very good. Okay, so this is how we figure out the shortcut. So instead of drawing out more frames, all right, what we're going to do is we're going to create a table with a big part in the middle. So there's going to be 3 parts to our table. On the left here, where we normally put X, I want you to write position, or you could write frame number or whatever. And on the right, we're going to have the numbers. And that's the number of squares that were in each frame. So what we're going to do is position 1, frame 1, we had 8. Position 2, 16, good. Position 3, 24. And position 4, 32, good. Okay, now what we have to do, we have to see how many we added to each frame. So from the first to the second, how many squares did we add? 8. So we're going to put plus 8. From 16 to 24, add 8. And from 24 to 32, add 8. Okay, this is a rule. If these are the same, then it is a sequence. So we have 8, 8, 8. So if it ever was different, so let's say it went 8, 6, 8, or 8, 9, 10, that would not be a sequence. Okay, then you would just stop there and say it's not a sequence. Alright, since it is a sequence, what we're going to do with this 8 is we're going to move it over here and say 8 times X, the position. Because the position was X. So we're going to do 8 times the position 1. 8 times position 2. 8 times position 3. And 8 times position 4. Now, 8 times 1 is 8. 8 times 2, 16. 8 times 3, good. And 8 times 4, 32. So if I'm making it for the nth term, that's just a general rule. So if I had position n, how would I figure that out? Times 8, right? So 8 times n. So that's going to be my general rule. Now, it seems pretty easy right now. That's how I got the 8, right? Okay, but not always is it going to come out to that perfect number, so we may have to add or subtract numbers over here to get back to our y value. Yes, I will demonstrate that. Let's go to number 2. Okay, so it already has, these are chips, right? They're already counted, so we need to write the positions. This is position 1, 2, 3, 4, 5. So I'm going to draw my table. Here's my position. Here's my chips. So position 1 I had, how many chips? 2. Position 2, 5, 3, 4, 11, and 5, 14. Good. Okay, so let's figure out how many chips we added every time. 2 to 5, added 3. Good. 5 to 8, 8 to 11, and 11 to 14, plus 3. Is this a sequence? Yes. So I'm going to take that 3. I'm doing 3 times my position. So I'm going to go down and write it like that. 3 times position 1. 3 times 2. 3 times 3. 3 times 4. 3 times 5. Three times 1 was 3 times 2, 3 times 3, 3 times 4, and 3 times 15. Sorry, 3 times 5, 15. Okay, now did these numbers work out to the y value? No. So if I have 3, how do I get to 2? Subtract 1. If I'm at 6, how do I get to 5? 9 to 8. 12 minus 1 is 11, and 15 minus 1 is 14, right? So my rule isn't just 3 times x, it's 3 times x minus 1. So when I'm trying to figure out the 9th term, okay, that's what they're asking for, the 9th term, what would I do here? Good. 3 times 9 minus 1. 3 times 9 is 27. Good. Minus 1 is 26. So for the 9th term, without having to draw anything, we know that that 9th stack is going to have 26 coins. Okay? Now I want you to try number 3. So when we're keeping these, what's 7 going to be? It's going to be 1, right? Position 1, 11 will be position 2. So I want you to come up with a table and figure out the nth term. So basically you're figuring out the shortcut. Okay, I want you guys to tell me what goes up here. Position. Okay, how many did I have? 5. So I have position 1, 2, 3, 4, 5. What went over here? The numbers, right? And what were they?
7.
Very good. All right, now from 7 to 11, I add 4. 11 to 15, 15 to 19, 19 to 23. Is this a sequence? Yes. So what do I do with the 4? Times x. Good. So 4 times x. So I'm going to write that down here. 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. How did I get from 4 to 7?
Add 3.
Good. 8 to 11?
Add 3.
12 to 15?
Add 3.
16 to 19?
3.
And 20 to 23? So my rule needs to be 4 times x. So to figure out the nth term, what do I need to do?
4 times x plus 3.
4 times x, or n, plus 3.